Hello, my name's Mr. Head, and welcome to ChemistryAid. Today we're going to focus on an engineering topic called centroids. Centroids are the center point of an object or a shape, a center of gravity, if you will. Think if you were trying to pick up a big long I-beam with a crane at a construction site. If you grab it at the end and you try to lift this I-beam up, it's going to start swinging because you're not picking it up at the center of gravity. I'm going to show you what I mean with a piece of paper that I have right over here. Say that I take this paper and I stab a hole right near one of the corners. This is not the center of gravity for the square. If I try to balance the object with much of the mass above the pencil, you'll notice it'll just go right back to this position. It doesn't matter where I start the rotation, it's always going to end up with most of the mass underneath that pivot point. Now, if I stab this object directly in the center, it should stay stationary. No matter what place I put it, you'll notice that it's staying in the same spot. That is because I stabbed this pencil through what is called the centroid of the shape. So putting this back, let me show you what I mean. You'll notice on the screen that there is a red square. With centroids, there is a rule of thumb with them that the centroid always must be along a line of symmetry. In fact, if the shape has multiple lines of symmetry, the centroid has to be at the intersection of those lines. So I'm going to put a red square up on the screen and actually draw two of the lines of symmetry, two of the diagonal lines of symmetry. You'll notice that those two lines of symmetry actually intersect at a point, really close to the center of the square, if not the center of the square itself. That must be where the centroid is. Now, it's great to kind of eyeball a centroid like this, but we do want to find out mathematically how we can determine where that centroid is. In order to do that, we're going to have to use a few different equations and the concept of geometry. So you'll notice that right now I'm going to put an x and y axis around the square. So I'm going to put two equations up on the screen. X, with a line over it, equals b divided by 2. And y with a line over it equals h divided by 2. Now, what do those variables stand for? Well, the x and the y with a line above it stand for centroids. Think about it. If the centroid exists in 2D space, we need to have an x-coordinate for it, where it is along the x-axis, and a y-coordinate for it, where it is along the y-axis. And that's why we have these two equations here. So to find where the centroid is along the x-axis, we're going to use the first equation. X with a line over it equals b divided by 2. B stands for base. So let's put some numbers in on these axes. You'll see 0 through 3. The base of the square goes to the third point along the x-axis. So to find out where the centroid is along the x-axis, we're going to take that 3, the base of the square, divide it by 2, and that will give us the answer 1.5. So we know that the centroid needs to be at the x-coordinate 1.5. It could be up, it could be down, it could be anywhere along that line, but it has to be there. So now we need to find out where the centroid is along the y-axis. We're going to use the second equation for this. You'll notice that we've got y with a line over it equals h divided by 2. Well, the height of the square is 2, so we plug that into the equation. 2 divided by 2 equals 1. So we know that the centroid must be at the first position along the y-axis. So we'll move the centroid up, and you'll notice that it's right in the middle of the square. We'll bring up the two lines of symmetry, and you'll notice that the centroid is exactly where it needs to be, right where those two lines of symmetry intersect. As we talked about before, I should be able to rotate this square along its centroid, and it should stay in that position. That is the center of gravity for the shape. So that's how you find the centroid for a square. It seems simple, and it really is, but if we add more complicated shapes, it's going to get a little bit tougher. So we wanted to start off easy. The next video is going to talk about how to find the centroid for a right triangle. There should be links in the description below on how to find that video. Thanks for tuning in to ChemistryAid.